Hello viewers, in today's class we are going to discuss one important and conceptual problem from inverse trigonometric functions, right? So here we are given one problem which is show that cot of pi by 4 minus 2 times cot inverse of 3 is equal to 7, right? So here we have to prove this expression, that is cot pi by 4 minus 2 times cot inverse of 3 is equal to 7, right? So this is a very interesting problem because here we are going to apply three important formulas from inverse trigonometric functions to arrive at this result, right? So let us start, but before proving this problem, let us first see the formulas which we are going to use. Now viewers, when we will solve this problem, there might be some different methods also, right? So in fact we can solve a problem in mathematics from different methods, but here the method which we are going to use will be utilizing three important results from inverse trigonometric functions, right? So the first result is cot inverse of x is equal to tan inverse of 1 over x whenever x is greater than 0, right? So this will be the first result, right, which we will use to prove this statement, right? And the second one is 2 times tan inverse of x is equal to tan inverse of 2x divided by 1 minus x square, right? And the condition is mod of x must be less than 1, right? So this is the second result which will be used here, right? And the third result is tan inverse x plus tan inverse of y is equal to tan inverse x plus y divided by 1 minus xy provided that x is greater than 0, y is greater than 0, and the product of x and y is less than 1, right? So this is the first one, this is the second one, this is the third one, right? So these formulas are very famous results, and we are already aware of these results, right? So now let us see how we can apply these results to prove this statement. So now let us take this cot term to this side, right? So now we can write pi by 4 minus 2 times cot inverse of 3 is equal to cot inverse of 7, right? So taking this cot to the right hand side, we have now this expression, right? Okay, now what we will do in this statement, we have cot inverse of 3 and cot inverse of 7, right? So we'll apply the first result over here, right? So pi by 4 minus 2 times cot inverse 3 can be written as the tan inverse 1 over 3, right? Because x is equal to 3 over here, so we have tan inverse 1 over 3, and when we apply this result to this term, we have cot inverse of 7, and that is equal to tan inverse of 1 over 7, right? Okay. Now let us rearrange this expression. So we can write 2 times of tan inverse of 1 over 3 plus tan inverse of 1 over 7 is equal to pi by 4, right? So initially we were given this statement. Now by applying this result, we have reduced this expression to this form, right? Okay, now let us see this term. Here we have 2 times tan inverse of 1 over 3, right? So now let us apply this result to this term. See, this is 2 tan inverse x and this is 2 tan inverse 1 over 3. So x is equal to 1 over 3, right? So now we can write tan inverse 2 times of x. So x is 1 over 3 divided by 1 minus 1 over 3 square, right? And here we have tan inverse of 1 over 7, and this is equal to pi by 4, right? So now let us simplify this expression. So we'll get tan inverse, this is 2 over 3, and here we have 1 minus 1 over 9, that is 8 over 9, right? So here we have 8 over 9, and here we have tan inverse of 1 over 7 is equal to pi by 4, right? Okay, now let us simplify it. So this is 3 3s are 9, and this is 2 4s are 8. So we have tan inverse of 1 over 4 by 3 plus tan inverse 1 over 7 is equal to pi by 4, right? So now we can write it tan inverse 3 over 4 plus tan inverse 1 over 7 is equal to pi by 4, right? So viewers, see, initially we were given this expression. Now we have reduced this expression to this one by making use of these two results, right? Now if we see the left hand side is tan inverse 3 over 4 plus tan inverse 1 over 7, right? And now we can apply this result to this expression. So now for x we have 3 over 4, and for y we have 1 over 7, and obviously the product of x and y, that is 3 by 4 times 1 over 7, is less than 1, right? Okay, so now this left hand side becomes, when we apply this rule, so we have tan inverse of x plus y. So x is 3 over 4, y is 1 over 7 divided by 1 minus 3 over 4 times 1 over 7. We can simplify it, tan inverse, and if we take LCM, we have 21 plus 4 over 28 divided by 28 minus 3 over 28, right? So now we have this term, 28 and 28 get cancelled, tan inverse, and this is 25 divided by 25, right? And 25 and 25 get cancelled, we are left with tan inverse of 1, right? And now we know that tan pi by 4 is equal to 1, because tan 45 degrees is equal to 1. So pi by 4 is obviously equal to tan inverse of 1, right? So here we can write pi by 4, and here in the right hand side we have pi by 4, right? So this is how we can solve this interesting problem by making use of these three important results from inverse trigonometric functions.